problem here of finding the derivative at a point. So we've gone over a couple and we've seen them before where we want to find the derivative of a function and our result is a function that tells us the derivative. Here we're going to find the derivative at a very specific point on f of x. So we're going to go through this problem twice. There's two different methods you can use to do this. Both are basically the same thing, just going in a slightly different order for two of the steps. So we're going to do the same problem twice in both ways. It doesn't really matter which way you use. So our question here is going to be find the slope of the line tangent to f of x equals x squared minus 7x plus 5 at x equals 3. And we're going to do this by using the definition of the derivative. So the first way is to find the actual derivative of our function and then evaluate f prime of 3. So let's take our original function here as f of x equals x squared minus 7x plus 5 and then run it through the definition of our derivative. We know the definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're just going to run this through. The limit as h approaches 0 of x plus h squared minus 7 times x plus h plus 5 minus our entire function x squared minus 7x plus 5 all over h. And we're just going to simplify this. The limit as h approaches 0. We're going to multiply this binomial times itself. Here we get x squared plus 2xh plus h squared minus 7x minus 7h plus 5. Distribute our negative. Minus x squared plus 7x minus 5 all over h becomes the limit as h approaches 0 of, we have a bunch of stuff here that cancels out, our x squared cancels with our negative x squared, our negative 7x with our positive 7x, our 5 with our negative 5. So we're left with 2xh plus h squared minus 7h all over h. So every term in the numerator has an h. So that's a good sign here. We'll factor that out and cancel that. The limit as h approaches 0 of h times the quantity 2x plus h minus 7 all over h. Those simplify out. And we're left with the limit as h approaches 0 of 2x plus h minus 7. And here we will we'll evaluate our limit, and we're going to get that this whole thing equals 2x minus 7. So we say that f prime of x equals 2x minus 7. So let's bring that up over here. So f prime of x equals 2x minus 7, and we're trying to evaluate here f prime of 3. So this is really straightforward now. We're going to just replace x for 3 in our derivative function. So f prime of 3, or the derivative 3 in our original function, is 2 times 3 minus 7. So f prime of 3 equals negative 1. And what this tells us, we've gone over before, that this function at the point, wherever x is 3, when x is 3, this function has a slope of negative 1. So now let's look at the other way to do this. We're going to evaluate f prime of x before taking the limit. So let's get our original function back up here. And we've got f of x equals x squared minus 7x plus 5. And when we said we're going to evaluate f prime of x before taking the limit, we're going to take the definition of our derivative, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. And what we're going to do is we're going to do it right now is where we're going to substitute in 3 for x. So we're going to have f prime of 3 equals the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. So the only difference we've got here from what we did before is instead of f of x plus h and minus f of x, we're going to just find f of 3 plus h and then subtract f of 3 from that. So you've got f prime of 3 equals the limit as h approaches 0. For f of 3 plus h, we just do 3 plus h squared minus 7 times 3 plus h plus 5. minus, and then f of 3 is going to be 3 squared minus 7 times 3 plus 5. And that whole last one's in parentheses there, all over h. And now we're just going to simplify this. We're going to multiply the binomials together, distribute the negative 7, all that fun stuff here. F prime of 3 equals the limit as h approaches 0 of, we're going to have 9 plus 6h plus h squared minus 21 minus 7h plus 5 minus 9 plus 21, we have 2 negatives there, minus 5, all over h. And you'll notice here in the numerator is a ton of stuff either adds to 0, cancels out, or combines together. We have a plus 9 and negative 9. We have a negative 21, we have a positive 21. We have a positive 5, we have a negative 5. Those all are gone. The constants all end up canceling out here, which is really great. And we have a couple things we can combine together. We can combine the positive 6h with the negative 7h. So we have the f prime of 3 equals the limit as h approaches 0 of, much shorter fraction bar now, negative h plus h squared all over h. And now we're going to factor our numerator. One of the h's out of there. We get f prime of 3 equals the limit as h approaches 0 of h times negative 1 plus h all over h. Our h's cancel. And we still haven't evaluated the limit yet, so we have f prime of 3 equals the limit as h approaches 0 of negative 1 plus h. And if, now we can just do this, we can say h is approaching 0, we just pop it right in here for h, and we're left with f prime of 3 equals negative 1, which is the same answer we got when we did it the other way. So either way, you're going through the definition of a derivative, but you definitely want to be familiar with both of these methods for our AP exam.